For years, scientists have searched for an alternative to iridium, a precious, rare, and extremely costly metal. Iridium plays a critical role in producing clean hydrogen fuel, but its scarcity has long stood in the way of global-scale adoption. Then came a breakthrough. In just one afternoon, researchers identified a promising substitute, thanks to a revolutionary new tool developed at Northwestern University. This tool, called a mega library, is unlike anything seen before. Imagine the world's first nanomaterial data factory, where millions of nanoparticles are carefully arranged on a chip no larger than your fingertip. Each particle is a new possibility, a candidate waiting to be tested. Working hand in hand with the Toyota Research Institute, the Northwestern team deployed this platform to rapidly screen catalysts for hydrogen generation. Once a promising candidate was identified, they scaled it up and proved it could perform inside a real device, all in record time. The Mega Library enabled scientists to test countless combinations of 4 abundant and inexpensive metals, each known for catalytic properties. From this vast screening process, they uncovered a brand new material. In the lab, it didn't just match iridium-based catalysts. In some cases, it outperformed them, at only a fraction of the cost. This success is not just about hydrogen. It demonstrates the power of the Mega Library itself, a tool that could transform how we discover materials in fields far beyond energy. As Northwestern's Chad A. Merkin explained, this tool unleashes the world's most powerful synthesis system. It allows scientists to explore an enormous range of chemical combinations and uncover materials that matter. In this project, the target was simple but urgent: find something as good as iridium, yet cheaper, more available, and more sustainable. Hydrogen production desperately needed this. Splitting water into hydrogen and oxygen, the key to clean fuel, is hindered by a difficult step known as the oxygen evolution reaction, or OER. Iridium is the best-known catalyst for OER, but it is rare, mined as a byproduct of platinum, and costs nearly $5,000 per ounce, more valuable than gold. There simply isn't enough iridium in the world to meet future demand. Enter the Mega Library's army of nanoparticles. Each library contains millions of tiny dots, each one a unique mix of metals formed into nanoparticles. Merkin described it vividly: instead of one person making one structure at a time, you have millions of tiny people, an entire army, working on a chip. On one such chip, the team created 156 million nanoparticles, made from different combinations of ruthenium, cobalt, manganese, and chromium. Robotic scanners then tested their performance, hunting for the strongest candidates. One composition stood out: Ru52Co33Mn9Cr6 oxide. This multi-metal catalyst combined the strengths of all 4 elements, producing a stable, highly active material. In fact, it performed slightly better than iridium itself, a remarkable feat. The real test, however, was durability. Long-term trials showed the new catalyst running for over 1,000 hours in a harsh acidic environment. Not only was it stable, but it was also dramatically cheaper, just 1/16 the cost of iridium. For Joseph Montoya, a senior scientist at TRI, the implications were clear: for the first time, we could screen catalysts rapidly and then watch them succeed in real devices. But the story doesn't end with hydrogen. By generating massive, high-quality datasets, Mega Libraries open the door for artificial intelligence and machine learning to accelerate discovery even further. Already, Northwestern and its partners are training algorithms to scan these libraries at unprecedented speeds. Merkin envisions a future where this approach revolutionizes every corner of materials science. From better batteries to fusion technologies, biomedical devices to advanced optics, the possibilities are endless. As he put it, the world does not use the best materials. It uses the ones we discovered at a certain time, with the tools we had. But now, we can flip that paradigm. We can truly find the best materials for every need, without compromise. Thanks for watching. If you are new to our channel, please subscribe to our channel and turn on the bell for further notification.